Welcome to solving radical equations. So anytime you have an equation with a radical in it, the steps are going to be to first isolate the radical. That means you want to get the term with the radical on one side and everything else on the other. To undo the radical, you're going to raise both sides to the inverse power. If you have the square root, you're going to raise it to the second power. If you have the cubed root, raise it to the third power, and so on. After you get rid of the radical, you're going to isolate the variable. You want an x equals as your answer. And finally, you're going to check for extraneous solutions. Anytime you have something funny in your equations, like if you have a rational equation, fractions, you need to check your answers. If you have radicals in your equations, you need to check your answers. So let's try the first one on the left. We want to get the square root of x by itself. So you're going to bring over the 11, and you're going to get the square root of x is equal to 6. You're going to square both sides to undo the radical, and you're going to get that x is equal to 6 squared, which is 36. Now, you don't have to actually write this out, but in your head, you should be checking 11 plus the square root of 36. Does that equal 17? And you get 11 plus 6 is equal to 17. So you get that, it actually works out. So you can keep your answer and say that x is equal to 36. On the right side, the radical is still not by itself. There's a 2 in front. So you're going to divide by 2 on both sides to get the cubed root of x is equal to 5. To undo the cubed root, this time you need to raise it to the third power. To get that x, because the inverse is the radical and the exponent undo each other, you get x is equal to 125. Now, check your answer to make sure it works. So 2 times the cubed root of 125, does that actually equal 10? So 2 times the cubed root of 125 is 5, and you get that 10 is equal to 10. It works, and you can keep your answer. For number 3, you have 2 things going on the left. I recommend that you always add and subtract before you divide. So bring over the 2 first. And now get rid of the 3 in front of the radical. Now that you have the radical by itself, square both sides. And you get that x is equal to 9. Check your work. When you plug in 9, do you get 7? Sorry, we should be plugging in 9. So 3 times the square root of 9, which is 3, minus 2, does that equal 7? And yeah, because you get 9 minus 2, which is equal to 7. So your answer checks out. Last one for example 4. We're going to get rid of the 2 that is outside of the radical. And you get that the square root of x minus 1 is equal to negative 6. Now, you're not going to bring over the 1 because that negative 1 is underneath the radical. So you have isolated the radical. The only thing on the left is the radical and what's inside of it. So you're going to go straight to squaring both sides. And you get x minus 1 is equal to negative 6 squared, which is 36. And you're going to add 1 to both sides to get that x is equal to 37. When you check your work for this one, the square root of 37 minus 1 plus 2, does that equal negative 4? Well, you get the square root of 36 plus 2, and the square root of 36 is 6. So you get that 8 equals negative 4, which is so not true, right? So because this doesn't hold true, we're going to reject x equals 37. It's an extraneous solution. So this one really has no solution, which you can also express as the empty set. Now, you didn't have to do all this work. Honestly, you could have just stopped. Let's see. We could have stopped when we were solving and got this part, that the square root of x minus 1 is equal to negative 6. And I'll write it on the side for us. The square root of x minus 1 is equal to negative 6. The reason why you can't have this as an answer is the square root of any number will always be positive. The square root of a number can never be negative. So as soon as you saw this, you should have known that there is no solution. And that's all there is for this video.